So this week we started a new unit, and so far you've learned how to calculate two things, work and kinetic energy. And right now, you may have a feeling that these two things are kind of random. So they each have a formula, but the formulas seem kind of weird, like you've never seen stuff like this before. Work is the dot product between force and displacement, and we defined a new thing called a dot product. And the formula for kinetic energy also looks kind of weird. Like, why is there a half in there? What's the purpose of having the half in there? And why is the speed squared? So right now, you really don't have much meaning. You don't have much meaning behind these two things. They seem kind of like random formulas. You can calculate them, but what are they useful for? Like, what about physics can this explain for us? But that's actually more of my goal for next week, is to show you the connection between work and kinetic energy. And then as the unit goes on, different kinds of energy as well. There's actually a really, really intimate connection, and that's going to be useful for us to solve practical problems about like actual objects and how they move. But we'll get there in the future. What I want to show you right now is that both of these things that we've defined with two seemingly very different formulas actually end up with the same units. Okay, and you should know that those units are called joules. So we started with work, and we made up a new unit called joules to be the units of measurement for work. And then I gave you a formula for kinetic energy, and I said that that also has a unit of joules. And I want to try to explain, or at least show, that they do have the same units, because it seems like they're built from completely different things. One of them is built from force and displacement. The other one is built from mass and speed. Okay, so they seem to be built from two seemingly like different things, yet they're supposed to have the same units. So I want to try to show you that they do. So I'm going to start with work. Work is force dot displacement. Okay, that is the magnitude of the force times the magnitude of the displacement times cosine of theta. And you've seen that before. Now, in terms of the units of all these things, the units of force, you should know, are newtons. The units of displacement are meters. And the units of cosine of theta, well, it's actually unitless. Okay, theta is in degrees, but the cosine of theta does not have any units at all. Okay, so the units of work can be stated as Newton meters. Okay, you can call them Newton meters. But I'm going to break this down a bit further. So newtons. Recall from Unit 2 that force, or at least net force, can equal to mass times acceleration. Okay, force equals mass times acceleration. So if we analyze the units there, force is in newtons, mass is in kilograms, and accelerations is in meters per second squared. So what I'm saying is that Newton can be replaced with kilogram meters per second squared. So if I'll replace newtons with kilograms meters per second squared. And then this meters here just gets copied down. Well, now I have kilogram meter per second squared times meters. But meters times meters is meters squared. Okay, so the units for work can be rewritten as kilogram meters squared per second squared. Now I'm going to go over to kinetic energy. So kinetic energy is half times mass times speed squared. The 1/2 does not have any units to it. It's just a half. So here's mass. Mass is measured in kilograms. And now this is speed squared. Speed squared. So speed is measured in meters per second, and it's getting squared. So we have kilograms, meters squared over seconds squared. Okay, it's the exact same as what I have in red on the left side. So I did all of this just to show that work and kinetic energy have the same units. And I guess this is the beginnings of showing you that these two things are really closely connected to each other. They have the same units. And we're just going to call them joules. And use the symbol of J, okay? Because we don't want to write kilogram meters squared per second squared all the time. That's a lot of writing. We don't even want to write Newton meters. We're just gonna simplify it and make up a new name for this unit and call it joules. All right, so that's the end of this unit. So next week, hopefully, we can focus more on why these two are connected to each other and solve some more practical problems.